Assalamu alaikum everyone, you are welcome at my class. Today we're going to talk about aldol condensation and mixed aldol condensation, the first experiment for the third class organic chemistry. Aldol condensation, this reaction is related to carbonyl compounds, especially for aldehyde and ketone, because they don't have any good living neighboring group at this position. So to explain the principle of aldol condensation, let's take the acetaldehyde as an example and explain the main condition for aldol condensation. First condition for aldol condensation, as a starting material we should have 2 moles or 2 molecules of same compound, same aldehyde or same ketones. And the structure of these starting materials should have alpha hydrogen, which is acidic hydrogen. What we mean by alpha hydrogen? The alpha hydrogens, those hydrogens which is attached directly to the alpha carbon. This alpha carbon attached directly to the carbon of carbonyl group. As a reagent we will use dilute base, KOH or NaOH solution. Just focus on this point. We talk about the concentration of base, dilute base or concentrated base. No, in aldol condensation we use dilute base. At the final we will get alpha beta unsaturated carbonyl compound, alpha beta ene alkene unsaturated center for carbonyl group. So alpha beta unsaturated carbonyl group. Again, we have 2 moles of same compounds, same ketone or same aldehyde. These aldehydes or ketones should be contain alpha hydrogen, acidic hydrogen. These molecules will combine together in the presence of dilute base to produce alpha beta unsaturated carbonyl compounds. Now, before explanation of mechanism of this reaction, we should explain acidic hydrogen or alpha hydrogen. Why we called on these hydrogens as acidic hydrogens? An alpha hydrogen is simple by alpha. The hydrogens is attached directly to the alpha carbon. The alpha carbon attached directly to the carbon of carbonyl compound. In this example for aldehyde, the other example for ketone. In ketone as acetone, we have 6 hydrogen acidic hydrogens. So why this hydrogens are acidic? Because of 2 reasons. The first one, a strong electron withdrawing effect of carbonyl group. As you know, carbonyl group has electron withdrawing effect because of the electronegativity of oxygen. The electronegativity means the tendency of an atom to attract the shared pair of electron or the electron density from other atoms to itself. The second reason is the stabilization of conjugated base, which clear in this slide. Look at the electrostatic potential for acetaldehyde. The more red color means the higher electron density. More blue color means lower electron density due to the electronegativity of oxygen, which makes more acidic hydrogen with less electron density. So we can abstract this hydrogen by any base. So let's take some examples of different organic compounds and decide which one will undergo and which one will not undergo with aldol condensation. First compound is aldehyde propanol, contains 2 alpha hydrogens, so it will undergo. The other one contains 2 alpha hydrogens, so will undergo. The other aldehyde, which is aromatic aldehyde, we call benzaldehyde, contains alpha carbon but without alpha hydrogen, so it will not undergo with aldol condensation. The final aldehyde contain alpha carbon without alpha hydrogen, so it will not undergo with aldol condensation. Those compounds, all of them are ketones. Some of them contain alpha hydrogens, so they will undergo with aldol condensation. The other two ketones, they do have alpha carbon but without any alpha hydrogen, so these ketones will not undergo with aldol condensation. As we said before, the most important condition for aldol condensation, the starting material should have alpha hydrogen. So any compound with alpha hydrogen, acetone or ketone, will undergo with aldol condensation. Any aldehyde or ketone without alpha hydrogen will not undergo with aldol condensation. To explain this, let's see the mechanism of the reaction of aldol condensation. As we said before, two molecules of same compound, aldehyde or ketone, as acetaldehyde as an example, at the first step we have dilute base OH negative charge anion will subtract this alpha hydrogen, this proton, without electron. This hydrogen is acidic hydrogen, so OH minus will subtract hydrogen without electron to produce carbanion, which is negative charge on the carbon. This negative charge will delocalize by tautomerism to form enol-enolate intermediate. This intermediate delocalized by tautomerism. We call tautomerism for this, not resonance, so because the resonance is special for aromatic ring. So whenever you have enol-enolate, so this process we call tautomerism. Now, this enol-enolate intermediate will attack an nucleophilic addition to the second molecule of same compound directly to the partially positive of carbon to break by bond and stabilize the negative charge on the oxygen in the second molecule. So now look to this arrow, will make a new bond between this carbon and the carbon of carbonyl. This is new bond, and the negative charge of oxygen will subtract the acidic hydrogen from H2O to produce beta carbonyl alpha beta hydroxyaldehyde as intermediate. So that's why we call aldol reaction aldehyde and alcohol. So it's mean aldol, it's mean aldehyde and alcohol, aldehyde and alcohol. So this is the main second step in this mechanism. This intermediate is dehydrated by presence of OH minus, still has alpha hydrogen, so this alpha hydrogen, this acidic hydrogen will subtract by the OH minus to produce H2O, and another intermediate which is easier to lose hydroxide from beta position to produce double bond and the position alpha beta. So the final product will be alpha beta unsaturated carbonyl, alpha beta unsaturated aldehyde, and another molecule of hydroxide, which is start over again and again and again. So this is the mechanism of aldol condensation. Should we have two molecules of same compound, aldehyde or a ketone, doesn't matter. Both of them contain alpha hydrogens in the presence of OH minus or dilute base. This alpha hydrogen will be easier to abstract without electron by hydroxide ion, because this hydrogen is acidic hydrogen, to produce enol-enolate. Why we called enol-enolate? En from alkene and ol from alcohol, so enol, and the derivatives of it enolate. So this is as a nucleophilic addition to the partially positive of carbonyl in the second molecules to make a new bond between this carbon and this carbon to produce beta hydroxyaldehyde. We called aldol product. This aldol product is easier to lose hydrogen because it still contains alpha hydrogen or acidic hydrogen. By excess of hydroxide ion produce molecule of H2O and produce carbanion, which make a double bond at the alpha beta position by losing other hydroxide, produce alpha beta carbonyl compound or alpha beta aldehyde or ketone and another molecules of hydroxide, and this hydroxide will start again. Now look at this H2O produced during the reaction, so that we call aldol condensation, not aldol reaction. There is difference between reaction and the condensation. The condensation is any reaction in chemistry will release a small atom like H2O or acetic acid as side product. So this is the mechanism of aldol condensation. I hope it's very clear. Now we have another type of aldol condensation we call mixed aldol or cross aldol. What the difference between mixed aldol condensation and the aldol condensation? Mixed or cross aldol is different between from aldol condensation because we have two moles of different compounds. Two moles, not same, different compounds, but at least one of them contains alpha hydrogen, one of them contains acidic hydrogen. So different compound, different starting material, different aldehyde or ketone, doesn't matter, but at least one of them contain alpha hydrogen with same condition, I mean dilute base. So this base will abstract the alpha hydrogen from acetophenone. Acetophenone will be convert to enol-enolate and attack at the second step the partially positive of benzaldehyde to produce at the final a compound we call benzyl acetophenone, which will do prepare it at the lab inshallah. The mechanism of the reaction between benzaldehyde and acetophenone same mechanism as we talk with the acetaldehyde, but at the different compounds. Now let's move to the practical section. We need a beaker, we need a round bottom flask, we need a magnetic stirrer, we need a stirrer device. Then in this beaker dissolve 2.2 gram of KOH or NaOH in 10 ml of H2O. Step 1, weigh 2.2 gram of KOH or NaOH and dissolve it by 10 ml of H2O. Then to this round bottom flask add 20 ml of ethanol and pour to this round 5 ml of acetophenone. Start stirring after connecting with the stirrer device. Start the stirring and then add another 4 ml of pure benzaldehyde to this round bottom flask. With stirring, drop-wise add this solution, drop by drop from the beaker, and keep the reaction temperature below 25 Celsius. Continue with the stirring for about 2 to 3 hours. Then remove the magnetic bar from the round bottom flask and leave the reaction mixture in ice sheet or refrigerator overnight. So this is part 1 for week 1. Round bottom flask, beaker, stirrer, magnetic stirrer. Put the magnetic stirrer in the round bottom flask. Add to this round bottom flask 20 ml of ethanol, 5 ml of acetophenone. Start stirring. Then add 4 ml of pure benzaldehyde. Continue stirring with addition or with added drop-wise of base solution from the beaker, drop by drop to the round bottom flask, and keep the reaction temperature below 25 Celsius. The stirring time about 2 to 3 hours. Then after that, remove the magnetic bar from the round bottom flask and then leave the mixture in the refrigerator overnight. For second week, start with filtrate the product with section on a Buchner funnel. Then wash this product with cold water until the washing or the filtrate are neutral to litmus, and then with 20 ml of ice cold ethanol to dissolve another impurity during the reaction. Then dry the product, recrystallize the product from ethanol, and calculate the percentage of yield. Our final product will be like pure benzyl acetophenone is a pale yellow solid, melting point of 56 to 57 Celsius. But at the lab, be careful because this product, this substance should be handled with great care since it acts as a skin irritant. So wear gloves during preparation of benzyl acetophenone. The structure of benzyl acetophenone this, and it is a skin irritant. So be careful when you prepare it. Now let's back to the procedure and explain some items. Why we use KOH or NaOH? Of course, as a source of OH or abstract materials. Why we use ethanol? Ethanol, of course, the solvent of reaction. Why we use acetophenone and benzaldehyde? Of course, both of them are starting materials. I think that's enough for today. And please read the experiment carefully. And if you have any questions, please write down and ask me when we meet together. Bye bye.